Hello everyone, I am Harika Shinde from Institute of Aeronautical Engineering and from Computer Science and Engineering branch. Today I am here to share and present my AAT concept video of a course Analog and Digital Electronics. My topic is construction of NPN transistor. Let's begin. Introduction. What is transistor? Transistor is a semiconductor device which is used to either amplify the signals or to act as an electrically controlled switch. A transistor is a three-terminal device and a small current or a voltage at one terminal will control a large flow of current between the other two terminals. Since a long time, the vacuum tubes are replaced with the transistors because the transistors have more benefits over vacuum tubes. Transistors are small in size and it requires low energy for operations, and also it has low power dissipation. The transistor is one of the important active components, that is a device which can produce an output signal higher power than that in the input signal. Transistor became an essential component in a modern electronics, and we cannot imagine the world without transistors. Transistor is an essential component is almost every electronic circuit like amplifiers, switching, oscillators, voltage regulators, power supply, and most importantly the digital logic ICs, that is integrated circuits. From the time of invention of the first transistor to the present day, transistors are classified into different types depending either on their construction or their operation. The following tree diagram explains a basic classification of a different transistor types. Transistor tree diagram. Here it is a tree diagram which shows a classification of a transistors. Now transistor is classified into a two types: BJT, bipolar junction transistor, and field effect transistors. Now BJT has again classified into NPN and PNP transistor. Now field effect transistor is classified into junction FET and metal oxide semiconductor FET. Junction FET again classified into a depletion mode. In depletion mode, it again classified as N channel and P channel. Metal oxide semiconductor FET has again classified as depletion mode and enhancement mode. Depletion mode has again classified as M channel and P channel. Enhancement mode has also again classified as M channel and P channel. Now, the classification of transistors can be easily understood by observing the above tree diagram. Transistors are basically classified into two types. They are bipolar junction transistors, that is BJT, field effect transistor, that is FET. BJTs are again classified into NPN and PNP transistors. The FET transistors are classified into JFET and MOSFET. Junction field effect transistors are further classified into N channel junction field effect transistor, P channel junction field effect transistor, depending on their construction. MOSFET are classified into depletion mode and enhancement mode. Again, depletion and enhancement mode transistors are further classified into respective N channel and P channel. Now, types of transistor. As mentioned earlier, on a broader scale, the major families of a transistors are BJTs and FETs. Irrespective of a family they belong to, all transistors have proper or specific arrangement of a different semiconductor materials. Commonly used semiconductor materials for manufacturing transistors are silicon, germanium, and gallium arsenide. Basically, transistor classified depending on their structure. Each type of a transistor have their own characteristics, advantages and disadvantages. Physically and structurally speaking, the difference between BJT and FET is that in BJT, both majority and minority charge carriers are required to operate, whereas in case field effect transistors, only majority charge carriers are required. Based on their properties and characters, some transistors are primarily used for switching purpose, and on the other hand, some are transistors used for amplification purpose. Some transistors are designed for both amplification and switching purpose. Now, junction transistor. Junction transistors are generally called as bipolar junction transistors. The term bipolar means both electrons and holes are required for conducting current, and the term junction means it contains PN junction, two junctions in fact. The BJTs have three terminals named emitter, E denoted with E, base denoted with B, collector denoted with C. The BJT transistors are classified into NPN and PNP transistors depending on their construction. BJTs are essentially current controlled devices. If small amount of a current flows through the base of a BJT transistor, then it causes a flow of large current from emitter to collector. The bipolar junction transistor have low input impedance and it causes to flow large current through the transistor. The bipolar junction transistors are only turned on by the input current which is given to the base terminal. BJTs can operate in three regions. They are cutoff region, active region, saturation region. Cutoff region. Here the transition is in off state, that is current flowing through the transistor is zero. It is basically an open switch. Active region. Here the transistor acts as an amplifier. Saturation region. Here the transistor is in fully on state and also works as a closed switch. NPN transistor. First definition. The transistor is in which one p-type material is placed between two n-type materials is known as NPN transistor. The NPN transistor amplifies the weak signal enter into the base and produces strong amplified signals at the collector. And in NPN transistor, the direction of the movement of an electron is from the emitter to collector region, due to which the current constitutes in the transistor. Such type of a transistor is mostly used in a circuit because their majority charge carriers are electrons, which have high mobility compared to the holes. Construction of NPN transistor. The NPN transistor has two diodes connected back to back. The diode on the left side is called as an emitter based diode, and the diode on the left side are called as a collector based diode. These names are given as per the name of the terminals. The NPN transistor has three terminals, namely emitter, collector, and base. The middle section of the NPN transistor is lightly doped and it is most important factor of the working of the transistor. The emitter is moderately doped and the collector is heavily doped. Here it is a picture which shows the emitter base collector of an NPN transistor. Now, circuit diagram of an NPN transistor. Circuit diagram of an NPN transistor is shown in the given figure below. The collector and the base circuit is connected in a reverse bias while the emitter and the base circuit is connected in a forward bias. The collector is always connected to the positive supply and the base is in negative supply for controlling on or off states of a transistor. The symbolic and structural representation of an NPN transistor. First picture shows the symbolic and all the rest pictures are a structural representation of an NPN transistor. Now, working of an NPN transistor. Circuit diagram of the NPN transistor is shown in the figure below. The forward biased is applied across the emitter base function and the reverse biased is applied across the collector base junction. The forward bias voltage VEB is small as compared to the reverse bias voltage denoted by VCB. Emitter of the NPN transistor is heavily doped. When the forward bias is applied across the emitter, the majority charge the base. This causes the emitter current IE. The electrons enter into the p-type material and combine with the holes. The base of the NPN transistor is lightly doped, due to which only a few electrons are combined, and remaining constitutes the basic current IB. This base current enters into the collector region. The reverse bias potential of a collector region applies the high attractive force on the electrons reaching collector junction, thus attract or collect the electrons at the collector. The whole of the emitter current is entered into the base. Thus, we can say that the emitter current is the sum of the collector and the base current. Thank you. This was my concept video of a course, analog and digital electronics. Thank you.